Today I'm joined by Julius Volz, one of the, we should probably get this correct, one of the co-creators, maintainers of PromQL, Prometheus. Like, what's the relationship there, and what was your involvement?
Yeah, both of those actually.
Okay.
I co-founded Prometheus together with Matt Proud at SoundCloud originally, coming from Google. That was 10 years ago by now, in 2012. I was back then responsible for coming up with this query language, which admittedly is very similar to the query language of the Borg monitoring system at Google, where we had just come from, but still has, plenty of its own functions and quirks and so on by now. But yeah, so I guess I can say I'm the creator, the original creator at least of PromQL.
Okay. That's interesting because, of course, Borg also became Kubernetes, which doesn't have a query language. So there's obviously some other things there that...
Yeah, Borg also didn't have a query language, but it kind of forms a nice kind of square of relationships right now. Borg inspired Kubernetes.
Yep.
BorgMon was used for monitoring stuff on Borg, and that inspired Prometheus. And Prometheus now works very well together with Kubernetes and vice versa. So there's a whole, and they both have these Greek origin names. So it all fits very well together.
Okay, cool. So you mentioned this query language, PromQL. Briefly, what is PromQL, and possibly most importantly, why would I want to use it with Prometheus? What am I trying to do with it in relation to Prometheus?
So PromQL is the Prometheus query language. The idea in Prometheus is that you collect a lot of data about your systems in the form of time series before you do anything else. And then to do anything useful with that data, you use the PromQL language to slice and dice your data, to select the right data that you want, to transform it, to aggregate over it, to do rate computations, to even do advanced computations between whole sets of time series, like arithmetic between whole groups of numbers that match together. That's a big innovation in PromQL. To then give you kind of answers about what is happening in your infrastructure, in your services. Is something going wrong? How many requests per second are you getting? What's the temperature in a given room, et cetera, et cetera. So really a functional language that is highly optimized towards doing time series computations and systems monitoring operations.
What were some of the design decisions behind PromQL? I think mostly from the perspective of a lot of people are familiar with the concept of a query language, MySQL and things like that in quote unquote traditional databases. So what was the design decision to create something new instead of leveraging something pre-existing?
So I think on a very practical level, we were creating Prometheus being inspired by BorgMon, and we had worked with BorgMon's query language. And admittedly, PromQL is quite similar to what BorgMon did. So on one hand, it was really, one reason was being inspired by that and not having to invent a full new query language from scratch, actually, because we already knew one. On the other hand, PromQL and also the BorgMon query language have the advantage of being very specialized towards time series computations, especially a concept in there that's called vector matching, where you can do binary operations, filter operations, and other types of operations between two entire sets of time series that have corresponding identities, so same label sets, and these operators will then automatically match up all the identical label sets of the both sides of the operator, do the operation between them, and give you a result. So as one example, for example, you may have 1,000 different hosts and their disk usage, and at the same time, you might have the total disk size for each of these same 1,000 hosts. Then you could take those 1,000 numbers on one side, the usages, divide them by the other 1,000 numbers on the other side, the total disk sizes, and you get a usage ratio out of that. And the binary operator does this automatic vector matching between the left and right-hand side, which is like almost basically automatic in PromQL and allows you to also modify it in certain flexible ways. And I would say like that's one of the biggest both innovations and powerful features of PromQL, but also one that, you know, allows you to shoot yourself in the foot if you don't quite use it correctly, unfortunately.
And what are some other, you mentioned a couple, but what are some of the most common queries, calculations, etc., that people might want to do with PromQL?
I think pretty standard systems monitoring ones. You have, for example, counter metric that tell you how many requests a given service is handling, right? And then you have a rate function to calculate the rate of increase of such a counter, whether that's requests or some other kind of event that is happening in a system. It tells you a rate per second of a counter. And then you may want to add a threshold to that to tell you, like, if certain rates are too high, for example, error rates, right? Or you may have histograms that tell you about the distribution of latencies of a service when it's handling requests. And then you have a function that goes together with that kind of histogram metric to tell you approximately what a 90th or 95th or 99th percentile, for example, would be for those request latencies. You may have a lot of these queries that just compute ratios or sums between things, like, you know, what the disk usage example that I just mentioned. You have predictive queries that would predict if the disk is going to run full in one day based on the last 4 hours of usage, for example, and so on and so on. So, you know, basically any kind of constructs that would help you monitor the request rates, error rates, latency distributions, utilizations, saturations, and so on of your services and systems. And yeah, it's very, I would say it's very varied what people use it for. So on one hand, you have these very big data center IT services use cases with thousands of microservices being monitored on a Kubernetes cluster and so on. But then you also have people just using Prometheus and the query language at home to monitor the temperature, humidity, and pressure to make sure that the dew point isn't reached, and so there wouldn't be mold in their bathroom. So, and then there's other people who use it to monitor their wind farm's power output and rotation angle of the individual windmills, for example. So quite varied, works pretty well for all kinds of systems monitoring style use cases that you have for any numeric data. But it's important to note that along with the data model, which only, you know, Prometheus only stores metrics, this language that goes along with that data model also only works on metrics. So if you have logs, traces, other kind of signal types, you would need to have a different system and a different language.